Hey guys, so welcome back to another video on partial differential equation. So on the last video we treated how to form PDE by elimination of arbitrary constants. So now I want to form PDE by elimination of arbitrary functions. So now if you can look at this is not a full equation. This is just z with respect to a function of x and y, x squared minus y squared. So this right here is a function, right? This is a function. So now we want to form a particular partial differential equation, but in order to do that, we have to eliminate this function. So we tend to assume that let p be equal to dz dx, and let q be equal to dz dy. So now if you look at this z is saying that z is a function of x and y, right? So z is a function of two independent variables, which is x and y. So now the first thing we do, let's differentiate with respect to x. So we have dz dx, right? So dz dx is equal to f prime. Remember, this is a function, this is not a full equation. So differentiating a function, you just indicate this f prime here, right? So this is f prime, so x minus y. So differentiating what is inside the function. So since I'm differentiating with respect to x, y is constant, so this is 0, this will be times multiplying it by 2x, right? So what I did here was take this, no, this is technically a function of function. This is a function of another function. So I differentiate the function itself and differentiate the function inside the function. So differentiate with respect to x, so this will be 2x and this one is 0. So that's why. So multiplying it by what you differentiated with. So this is dz dx. So differentiating with respect to y, so let's differentiate with respect to y. So this will be dz dy equal to f prime of x squared minus y squared. That is, I've differentiated the function. Then differentiating what's inside the function, this will be multiplying minus 2y, right? Because since I'm differentiating with respect to y, x is a constant. So differentiating a constant is 0. So this is minus 2y. So now, in order to eliminate this function, what do I need to do? I can make this function subject of formula and equate the two equations, or technically I can just divide the equation through. That will be much easier. But let's just follow the basic method of just for basic understanding. So what I do here, so since I call this equation 1 and I call this equation 2. So making for my function of y in equation y, in my function of x and y in equation 1, the subject of formula, this will be dz dx dividing through, so this is 1 over 2xy, right? So I made this one subject of formula in equation 1. And remember, dz dx is p, right? So we can just say p times 1 over 2xy. So this is my function in equation 1. So let's call this equation 3. So my function of x and y in equation 2, let's make it subject of formula. This will be function of x squared y squared equals dz dy divided by minus 1 over 2y. So since dz dy is q, so we can say q times minus 1 over 2y. So this is my function of x and y let's call this in equation 2, let's call this equation 4. So we can equate equation 3 and equation 4 together, equating this and equating this, right? So we'll be left with p times 1 over 2x is equal to q times minus 1 over 2y, right? So we can just say p divided by q is equal to minus 2x, that's cross multiplying, right? Dividing through and cross multiplying this, minus 2x over 2y. So 2 cancel 2, so we can say p over q is equal to minus x over y. So this is the PDE, the partial differential equation. But if I'm saying, why is it always in terms of p and q? Or you can just rewrite it as, since my p, why is it always in terms of p and q? So we can just say p is equal to minus x over y times q, right? You can try to leave it in its normal form. So where p is dz dx minus x over y times my q, which is dz dy. So this is a partial differential equation in its usual form. So you can leave it this way, still the same. So this is how to form a partial differential equation by elimination of arbitrary functions. So thank you guys for watching, and please do so well to subscribe. Peace.